This is Physics 2 Lab 1 charge tapes. The purpose of this experiment is to learn about charges and their interactions using everyday objects. In this lab, excess charge remaining on the charge tapes was also calculated. The result of this lab was that the system of the two U-tapes repel each other as they are of the same charge, which was found to be positive, and that the forces of gravity and electricity were found to be tangible, equal, and opposite to each other. The fundamental principles used in this lab were Coulomb's law and the superposition principle. In this experiment, we assumed that air resistance is negligible, tape is treated as a point charge, charge is concentrated at the center of the tape, and that each tape has the same and evenly distributed charge. I had to determine the sign of the charge tapes. For the two U-tapes, they repulsed each other. The U-tape and the hand attracted each other, the U-tape and the table attracted each other, and the U-tape and the negatively charged pen attracted each other. So I was able to conclude that the two U-tapes were of equal charge and that the charge was positive. The data used in my lab was that the length of the tape was 0.2 meters, the width of the tape was 0.02 meters, the distance between the two tapes was 0.3 meters, and that each tape weighed 0.0002 kilograms. The acceleration due to gravity was 9.1 meters per second squared. The charge of an electron is 1.6 times 10 to the negative 19 coulombs. The area of an atom, which is the length of the atom squared, came out to be 1 times 10 to the negative 20 meters squared. The area of the tape was equal to the length of the tape times the width of the tape and came out to be 4.0 times 10 to the negative 3 meters squared. Using the data, I was able to do these calculations. The gravitational force was equal to mass times gravity and came out to be 1.6 times 10 to the 3 newtons. The electric force was a negative mass times gravity, so it had the opposite sign of the gravitational force and the same value, so it's negative 1.96 times 10 to the 3 newtons. The electric field was K times Q divided by R hat squared, and we found that Q is equal to 1.4 times 10 to the negative 8 newtons, and this is where the fundamental principles were applied. The number of excess electrons is equal to big Q divided by small q, so that came out to be 9.33 times 10 to the negative 19. The number of atoms is equal to the area of the tape divided by the length of the atom, and that's equal to 4.0 times 10 to the 17. The electrons per atom came out to be 2.2 times 10 to the negative 7, and this was solved by number of electrons divided by number of atoms. The code in GlowScript is depicted here, as well as the model that the code showed. The calculations and data that I presented in the previous two slides were applied to the code, as well as code that created the arrows and dots seen in the model. I used the formulas for excess electrons on the tape, number of atoms on the tape, number of electrons per atom, and the charge on the tape. As you can see, the model depicts said charges and values, and the values are what I discussed on the previous slide, were also equivalent in the values that came out from the code. To answer the what if question, we have what if electrons had positive charge and protons had negative charge? What would change about the observations that I made with my tapes and other charged objects? The answer is that the direction of the electric fields would flip, and that the tapes would be at opposite charge, as well as the signs of the calculation would be opposite. However, if the charges were equal and opposite, it would not change the way that the objects behave, simply the signs of the calculations. To answer the why question, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? It's important to not handle the charged tapes that much because the charge from the tapes will transfer to the neutral object in contact, which could be my hands or the object that is in contact like the table or the pen. Thank you.